Welcome. I am so incredibly excited to partner with you on this GF12000 Drillship Masterclass. Now, this curriculum is designed to build a really deep, working engineering knowledge of 6th and 7th generation drill ships. We're literally going to take a floating city made of steel, pull it completely apart, and understand exactly how it works. Whether you're looking at the hull, the massive power plant, or the drilling equipment, by the end of this journey, you're going to understand the whole shebang at a working engineer's level.
Okay, let's dive right into this. Here is our highly structured orientation schedule for today's syllabus. We'll start off by assessing your baseline. Then we'll look at the shear scale of the GF12000 and cover the rule of redundancy. After that, we'll map out the 8 core modules of our curriculum. And finally, you'll choose your learning path. All right, up first, assessing your baseline. Before we even touch a single piece of equipment, we kind of need to talk about you. To help me tailor this guide exactly to your needs, I have to ask, what is your main goal for this study, and how familiar are you currently with marine or drilling engineering? Like, for example, are you starting completely from scratch, or do you already have some technical or field experience under your belt? Take a quick second to think about that. Because look, whether you're a complete novice seeking foundational knowledge or an experienced offshore hand who just needs a solid refresher, this explainer is tailored entirely for you. If you're starting from scratch, we're going to build your knowledge step by step. But if you're an experienced hand, this is going to be a highly structured, comprehensive refresher. Either way, you walk away with a much deeper mastery. Moving right along to Section 2, the scale of the GF12000. Before we get our hands dirty with thrusters or blowout preventers, we really must understand the absolute physical magnitude of the beast we're conquering. 12,000. That is the maximum water depth rating in feet for this drill ship. That is a depth twice that of the Grand Canyon. And honestly, the most incredible part, the vessel operates all the way down there entirely without anchors. I mean, you simply cannot drop a chain in 12,000 feet of water. So how in the world does it stay in one place? Well, the answer is 33. That's the total installed thrust power in megawatts, generated by 6 retractable azimuthing thrusters bolted right to the bottom of the hull. That is literally enough electricity to power a small town, and all of it is being used just to hold this massive ship within 1 meter of its set point against ocean waves, wind, and wild currents. And this brilliantly illustrates that beyond just power, there is sheer cargo capacity. We are looking at 3,600 square meters of open deck space. That's enough to park over 500 cars. While drilling, it safely floats a variable deck load of 22,000 metric tons. To put that into perspective, that is the equivalent of 100 fully loaded Boeing 747s just resting on the deck, completely filled with riser joints, drill pipe, and mud. It's a massive floating industrial complex. Which brings us to Section 3, the rule of redundancy. Now, this is the beating heart of our masterclass. It's the unifying engineering motif that governs every single system on board. Ready? No single failure ends the story. Let me say that again because it's absolutely crucial. No single failure ends the story. When you have a vessel connected to a live oil well beneath 12,000 feet of water, a blackout or an engine fire simply cannot result in a loss of position. This is the ultimate ground rule of the ship's entire design philosophy. So the crucial point is how they actually achieve that rule in the real world. It's called DP Class 3, or DP3. This is the highest dynamic positioning certification available, and it mandates strict physical and electrical separation. Basically, the GF12000 has 42 megawatts of power across 6 engines, but they are physically separated into 3 distinct engine rooms divided by A60 fire-rated bulkheads. So, if a catastrophic fire destroys one entire engine room, which would be a nightmare, the ship still has enough isolated power and control to safely hold position. Out here, redundancy means physical separation, not just duplication. All right, let's jump into Section 4, mapping the 8 modules. Let's unroll the map of the territory so you know exactly what technical ground we're going to conquer together. Once we establish your baseline, we can customize our journey through the 8 core modules. Module 1 covers general arrangement and hull specifications. Think vessel dimensions, operating drafts, displacements, the moon pool layout, and deck loads. Module 2 details the retractable canister system and thrusters, covering propulsion, jacking systems, and auxiliary steering, lubrication, and cooling loops. Then, Module 3 dives into Dynamic Positioning Class 3, focusing on DP3 consequence redundancy, position reference sensors like HIPAP and DGPS, and alarm logic.
Finally, Module 4 connects the ship to the seabed with the active heave drawworks and riser systems, breaking down active heave compensation, regenerative braking, marine risers, and tensioners.
Now, what's really interesting about this slide is that this entire first half of the curriculum focuses solely on the vessel's physical envelope and how it holds station. We're going to explore some truly fascinating mechanics here. Like, take that massive active heave drawworks winch system. It actually counteracts the rising and falling of the ocean waves in real time, paying out and reeling in cables so the drill string remains perfectly still relative to the seabed. It is just a stunning piece of engineering. Then, once the ship is firmly locked in position, we transition to Part 2. Module 5 scales the derrick and drilling equipment, unpacking the dual dynamic derrick, top drives, automated tubular handling, mud processing, and subsea BOP stacks. Module 6 takes us into power generation and electrical distribution, looking at main diesel generators, 11 kV high voltage distribution, low voltage networks, and the power management system. Module 7 covers control, instrumentation, and safety systems, including integrated automation, zoned emergency shutdowns, and fire and gas detection. And lastly, Module 8 looks at navigation and communication equipment, highlighting bridge electronics, radars, speed logs, and emergency communication systems. Across this second half, we're literally tracing the journey of 42 megawatts of raw power from those diesel generators all the way down to the subsea blowout preventer stack. We'll learn exactly how the dual derrick handles two independent heavy pipe loads at the exact same time, and we'll end up on the bridge looking at blackout-proof systems like sound-powered telephones that keep everyone safe and connected, even if every ounce of electricity is completely lost. And finally, Section 5, choosing your learning path. So, you now know the shape of the vessel, the massive scale of the operations, the golden rule of redundancy, and the map of our 8 core modules. Now it is time for you to take charge of your educational journey. Once you share your goals and experience level, we can dive right into Module 1, or honestly, any specific system you want to tackle first. So tell me, where would you like to begin?